Good morning, student. I hope you all are fit and fine, and also hope that you are preparing for your examination, which is going to be held. The date will be soon announced about the half-yearly examination. Children, in the last class, I was revising the chapter motion. In that, I have explained or I have revised the topic motion. In that, types of motion, that is uniform motion, motion along a straight line, non-uniform motion, and motion along a circular path. Second, measurement of motion. In the measurement of motion, I have discussed distance, displacement, speed, velocity, acceleration, and all these things. Now, then today I am going to explain about the measurement of motion by the method called graphical representation of motion. How you represent the motion by graphical method, and with the help of this graphical method, how you will derive the equation of motion also. Now let us see. First we will discuss about the graphical representation of motion. Graphical representation of motion, first case we will discuss about the distance or displacement. Children, in the case of graphical representation, one thing you should remember, while representing the motion in a graphical form, here we consider distance and displacement may be same, but actually distance and displacement both are different terms, and you have studied about the differences between distance and displacement, but only for the graphical representation we consider distance and displacement as the same. So if we write here first that distance time graph or displacement time graph, distance time graph, or you can say displacement time graph. By the term, here we are using distance time graph, and here we are using the term displacement time graph. In the case of graphical representation, we consider both as the same. What we obtain with this graph by plotting distance time or displacement time, the slope of this graph will give you the physical quantity that is called speed or velocity. When you obtain the slope between the distance time graph or displacement time graph, if you are writing the displacement time graph, then the slope of the displacement time graph, with the help of this you can calculate the velocity, or the slope of distance time graph you can calculate the term called speed. So for this, what are the conditions to represent the graphically in the case of distance time graph or displacement time? First case is for uniform speed. The distance time graph is in y-axis or x-axis. We will represent here time. Here we will represent distance or displacement. Displacement, or you can write distance. In meter. For uniform speed, what you will see, the graph obtained is a straight line, and suppose different points are given, you take any point D1, D2, here T1, T2. You write here A, B. So, slope of the graph, slope AB of the graph, slope AB of the graph is equal to what? You write here C, that is BC upon AC. That will be equal to what? BC is D2 minus D1 upon T2 minus T1. So this gives the what? Physical quantity? The speed, or you can say or velocity. You can calculate speed or velocity. So for uniform speed, the graph is a straight line, and with the help of this you can obtain or calculate the velocity. Now for the next case, when the object is at rest, number B. Number B is when the object is at rest. Then what type of graph you will get for distance time graph or displacement time graph? Time, displacement or distance. Time in second. It will be parallel to the time axis. The graph, the distance time graph showing the representation parallel to the time axis. Parallel to the time axis. When the displacement is parallel to the time axis, this shows that object is at rest position. The object is not in motion. Now, the third case is number C, for non-uniform motion. For non-uniform motion, time here we write distance or displacement. For non-uniform motion, the graph is in this way, curve. When the graph is in the form of curve, this shows that object is not in uniform motion, they are in non-uniform motion. Means the distance or the displacement covered by the body is not equal in equal interval of time. So this is the first case to plot distance time graph, and with the help of distance time graph we can calculate the physical quantity that is called velocity or speed. Now let us move to the second representation of motion that is called velocity time graph. With the help of velocity time graph, we can calculate the acceleration of the body. With the help of velocity time graph, we can calculate the acceleration of the body. Here also, we are taking different conditions to plot the velocity time graph. So let us see what are the different graphical representation of velocity time graph. Now let us see. Now let us see the graphical representation of motion, that is velocity time graph. For the first case, here the uniform acceleration means, I have already told you, with the help of velocity time graph, the physical quantity which we can calculate is, that is acceleration. So for uniform acceleration, when the initial velocity is not zero, though graph is in a straight line. If initial velocity is not zero, then the straight line graph is from here. Here you are writing C, U is the initial velocity, and here final velocity V. So slope of velocity time graph here, slope of Vt equal to what? That is OB minus OA upon here. This is T2 minus T1. OB is what? V minus U upon T2 minus T1 is T. And this gives the representation of acceleration, and this becomes your AT equal to V minus U, or V equal to U plus AT. We will derive it later on with the help of this graph, how to derive the different equation of motion. But this graph represents the uniform acceleration of the body when the initial velocity is not zero. Here you see the graph of velocity time graph. Here the velocity is decreasing and ultimately it comes to zero and intersect at x-axis here. This shows that this is the uniform retardation. Uniform retardation means velocity is decreasing as the time passes. As the time increases, the velocity is decreasing uniformly. So this is also called uniform retardation or negative acceleration. Here the velocity is not changing as the time passes. The velocity of the body is not changing. It remains same. So the body is having here zero acceleration, means no acceleration. So these are the three conditions by which you can represent the velocity time graph. Now let us move to the next part of this chapter, that is how to derive the equation of motion with the help of graphical method, that when the object is having some initial velocity. So we will move in detail of this part to derive all the three equations of motion with the help of graphical method. Now let us see. Now student, how to derive the equation of motion, that is three equation of motion you have learned, that is V equal to U plus AT, S equal to UT plus half AT square, and third is V square equal to U square plus 2AS. How to derive this equation with the help of graphical method. Here student, I have plotted a graph of the object or the body which has certain initial velocity and having uniform acceleration. So it is not originated from zero, because this body has certain velocity, initial velocity, and its velocity is increasing uniformly. And children, you know that with the help of velocity time graph, we can calculate the physical quantity that is called acceleration. So here I have written some terms. Here you know that u is not equal to 0. OA is equal to u and BC is equal to V. AD equal to OC equal to T. Now slope of velocity time graph will be BD upon AD. BD upon AD. So BD we can write it how? BC minus CD. So I have written here BC minus CD upon AD. Now this slope of velocity time graph gives acceleration A. Now A is equal to BC. BC is what? V. And CD is equal to OA के बराबर है. CD, since you know CD is equal to OA, that is equal to U. So V minus U, and AD is equal to OC. That is equal to T. Now you transport transposition of T to this side, it will become AT is equal to V minus U, or you can say V equal to U plus AT. Now see children, this is your first equation of motion. This is your first equation of motion. This is the first equation of motion. Now let us see the second equation of motion. How to derive? You can write it down if you want to write it down. Now second equation of motion. How to derive the second equation of motion? Now in the case of second equation of motion, what we will take? We will take the area covered by velocity time graph. What does it give? The area covered by the velocity time graph gives the distance displacement, or you can say distance. So here area covered by velocity time graph, that is equal to what? Area of trapezium. Trapezium OABC. OABC. Since you know that area covered by the velocity time graph gives the value of displacement or distance. Displacement, that is S. That is equal to area of trapezium. Area of trapezium, you know that half into sum of parallel sides into distance between them. Distance between them. That is S equal to half into parallel side OA plus BC into distance between them is OC. So S is equal to, you can write here, OA is U and BC, you know that OA is equal to U and BC is equal to V. So V upon 2 into OC is equal to how much? That is equal to T. So into T. Now, since you know that in the first equation you have derived V is equal to U plus AT. So on substituting the value of V here, what we will get? S is equal to U plus AT upon 2 into T. Now I am writing here see here S is equal to 2ut upon 2 plus AT square upon 2. 2 cancel. So S is equal to ut plus half AT square. So this is the second equation of motion. So this is the second equation of motion. This is the second equation of motion. Now let us move to the third equation of motion, how to derive. Children, for the third equation of motion, it is very easy that what you have to do, till here you will write the same thing, displacement, that is area of trapezium, half sum of the other side into distance between them, then half OA plus BC to OC, V plus U plus V into T upon 2. Now what we will do, we will substitute the value of T here. T is equal to what? V minus U upon A. Since we know that T is equal to V minus U upon A. So here we can write S is equal to V plus U upon 2 into V minus U upon A. Now you can write this here, S is equal to 2A V plus U into V minus U. See, A plus B, A minus B. The formula you know that S is equal to V square minus U square upon 2A. Now you transpose this 2A to here. What you will get? 2AS is equal to V square minus U square. Now you transpose the minus U square to this side, you will get final equation V square is equal to U square plus 2AS. So this is your third equation of motion. So children, in this way you can derive the all three equations with the help of graphical representation by plotting the graph velocity time graph. Now we will move to the next part of this topic, that is the circular motion. What do you mean by circular motion? You have already learned about the motion along a straight line. In that you have learned uniform motion, non-uniform motion. Now by the word hearing the circular motion, it is simple that the body is moving in a circular path. Means when a body is moving in a circular path with a constant speed, velocity is not constant, only the speed is constant, then you can say that body is having a circular motion. So let us see one or two questions related to MCQ type. What type of questions is going to be asked in the half yearly examination? MCQ based question. One or two questions I am giving you as example. Let us see now. Now children, let us see some few objective types question related to the topic which I have taught you. The first is area below velocity time graph is a measure of. Just now I have discussed when I have proving the equation of motion that area covered under the graph of velocity time graph, that what it gives? It gives displacement. Here the four choice is given: acceleration, displacement, angular speed and angular displacement. The correct choice is the area below velocity time graph is a measure of displacement. The second question is, if the velocity of a body is reducing, it is said to have. First option is negative acceleration, second is retardation, third is positive acceleration, and D is both A and B. So here you see, if the velocity of a body is reducing, it is said to have. Reducing velocity, I have already told you, that is negative acceleration or retardation. So last choice is given here, option both A and B is correct. So this type of question is going to be asked in half yearly examination, and also the numerical part will be also in the MCQ form. You have to solve it and put the correct option there of the numerical answers. So I hope you have understood what type of question is going to be asked in half yearly examination. Now children, please do revise your chapter very sincerely and stay at home, be safe. Hope we will meet you again in the next class. Till then, thank you. Have a nice day, children.